Hello, hi, good morning, good evening, good afternoon, everybody. And yeah, welcome to Discover Neo4j AuraDB free with Michael and Alexander. A strange new angle, Michael, you have today.
Oh,
I don't know, your camera.
that's still from notes. Oh, let me see if that's actually the right camera.
I don't think it's the right
Because
camera. It's like
it seems that the where is this
frog perspective. Hi,
Yeah,
Lenny.
frog perspective is not good. Let's see. Yeah, it switched the camera for whatever reason. So this should be better now.
Didn't change the camera.
Do I need to remove and add it again or something like that? Or?
Maybe. Let me see.
I just changed it in settings that it should use the other camera.
Yeah.
Oh, it just refuses it. I select the camera and then it just switches back to the old one.
Exactly. It's
whatever. So I can give me a second. I'll try to fix it.
Yep. I'll see when it changed back. So it gives me time to actually talk about. Oh, here we go. This was quicker than I thought. Here it is. That much better. Now you're muted though. Unmute. No, microphone. Your mic is not connected. Is what it says. Oh yeah, here we go.
Now
it works. All right.
Good. Yeah, it was the old notes setup, but for some reason I just unplugged it and plugged it in again, and now it worked. So the usual computer function restarted, and it works again.
Oh, cool.
Cool. Sorry.
Good afternoon, John. Hi, Lenny. I think audio should be working now. Hi, Rashandra. Thank you for joining you all. This is the Aura free discover data sets, have fun with data sets, learn that you can get from a table into graph within 60 minutes. So this is what we do regularly. So if you are watching for the first time, we will show you what's doing. If you are watching this regularly, then you know what's coming. As I said in the chat in the beginning, if you new to Aura or have tried Aura, if you have any feedback, any questions, anything else, this is also a way to ask some of these. We have not infinite amount of time to answer all the questions, but if it's something we can answer, obviously we try to make that happen. So hands on with AuraDB free. So what's the plan? I'll quickly show you or explain to you what is AuraDB free and give a quick overview. And then generally what's happening is that we pick a data set. If any of you have a data set that is interesting, you saw something on Kaggle, you have a data set you saw somewhere else, you have a data set you own yourself and you think it's interesting, it obviously has to be shared publicly. Let us know, ping us on Twitter, on Discord, on the community forums, anywhere else, and we can have a look at it and use it. Then we look at the data set, we think about questions we might ask, we come up with a data model to support the questions, to support the queries, and then we load the data in Aura and run some queries, maybe show some visualization, depends on the data set, depends on the questions, and then we are ready to explore more. What's AuraDB free? AuraDB free is the free version, obviously, of Neo4j AuraDB. AuraDB is the graph database as a service offering that is now, since 2 weeks, at least in the paid tiers, available on all major cloud platforms. So that means Google Cloud, AWS, as well as Microsoft Azure. So no worries if you are previously. It was a little bit of a hassle, but if you are on any of these, you can use Aura, the database as a service. You can use Neo4j in itself on all these platforms, on dozens more. So if you are wondering if you can use Neo4j in the cloud, the answer is probably yes. It depends on your setup and on your preferred providers, but on the major platforms it's available. But with AuraDB as a database as a service type offering, we are now on these 3 major ones. So that's good, and you have the choice what you want to do. The limitation of AuraDB free is that it is limited to 200,000 nodes and 400,000 relationships. So that means you can work with that. I think we showed in over the past episodes that we don't come across this limitation a lot. Sometimes it is the data sets are a little bit too big, so we had to cut it down a little bit. But to work out a proof of concept, a test case, a trial run, it's plenty and it's enough to give it a shot. And then once you realize, okay, actually I need more space, with AuraDB you can always upgrade to professional, which is not too expensive if you need more, and you'll get rid of this limitation easily. You get Neo4j Bloom and browser, which is a visualization part as well as the query part. You always know, which was there for a long time. Data importer is somewhat new. It's also for you to, and I guess we show that later, to see how it works to get data in Neo4j. And then to combine all of this, we have a new workspace, what do we say, platform, tool. Which because Bloom, browser, and data importer previously were either different apps or different browser windows. At least you had to open up, and with Workspace everything is in one place. You just have to switch between the different tools without juggling around browser windows. So that's very cool. It's free forever, so that's also very important. As long as you like it, like to use it, you can use it. It doesn't expire after an amount of days or whatever gigabytes of use. And with this link you get it. I'll post a link in chat. And today Michael had the idea to do AWS services. So here we go. Here's the link to Aura. I'll switch over to Michael's screen now.
Okay.
And maybe before we do that, we can answer Ahmed's question on nodes, because nodes,
exactly.
2 weeks ago, we had
which
Ahmed wants to know.
Hopefully seen.
Yeah, exactly. Only beginner track videos uploaded to YouTube channel. Any plans to publish the intermediate and advanced tracks on YouTube as well? So yes,
actually, all the content is on YouTube now. So I just pasted a link into chat, which should go to the YouTube playlist, and you have all 106 videos there, and you should see all of them in the playlist. What was on YouTube before was what we had live streamed, and that's why it was on YouTube already. But last week I uploaded everything into the playlist, and also if you look at it, there is also in each description. We also added slides as well, and some tags and some additional links for things as well. So you can basically find all the content and watch all the videos from notes. So you have a lot to do, I would say. Right? So there's a lot of really good content, I have to say. It's watching some of them live while kind of running behind the scenes was really impressive. Like the quality of the content and the speakers was really good. And on data science, on graph visualization, on app development, cybersecurity, data migrations, you name it, GraphQL, lots of healthcare, several Bitcoin fraud, cryptocurrency ones, and Python, Java, and much more. So there's a wide range of talks, and there's something for everyone, I think.
Yeah, definitely. So there is, lots of interesting sessions, lots of interesting topics. So yeah.
No, it's all good. I mean, we wanted to talk about this anyway, so so that was a good segue. Question. Actually, I should do a blog post about it. So I spent a lot of time last week with the YouTube APIs, and they're really frustrating and annoying, and it was so complicated to get this all done. And then in the end, I realized that updating 100 videos, the descriptions takes away 50% of your daily quota on YouTube. So you can do this twice a day, and then you have to wait a full other day. And they actually denied my quota extension requests because they didn't see what my problem was. And, so But I learned quite a lot that I didn't want to learn. But cool.
Yeah, maybe worth to give a little shot.
I'll do a blog post at some point.
Obviously, if you find a particular video very interesting, give it some thumbs ups or add your comment.
Or share it on LinkedIn or Twitter.
Exactly,
or social.
Share it further, so the video gets more views. And one or two maybe I can invite to a stream in the future for a longer session, where there were maybe only 15 minutes lightning talks, to give them a little bit more space for the session.
There's another question.
On Rust from coding
Rust
with Alxor.
So actually, there are a bunch of Rust Neo4j drivers.
Yep.
There is there's repositories here. So I played around with this one here, the first one, Neo4rs. I think someone from the driver team is actually working on this one. But I wanted to latest next year, I wanted to pick up like different drivers again. So the R driver, the Rust driver, the PHP driver, and also update the language pages for those as such. But this one actually worked quite well for me. The Neo4j Neo4rs. So I played around a little bit with it, and it was actually quite easy to go as such. But we'll look into that in more detail as such. Cool. So Alex and I were talking earlier, and what kind of data set we want to look at, and then I remembered that this week is AWS reInvent. And so I thought, and Neo4j actually has a booth at reInvent. So if you know anyone who is at reInvent, you can let them know that they can go visit the Neo4j folks and say hi from us. So AWS reInvent is basically the big conference, or one of the big events of AWS, where they launch a lot of like services and talk about what they're doing and like all the different ways how you can basically build better cloud systems on AWS. And I remembered that a few years ago, Aidan submitted an AWS Web Services global infrastructure graph. And I thought, why should we not basically look at the AWS infrastructure as a graph today, because it's kind of fitting from a theme perspective. And that's what we wanted to try out today. So if you go here, you see basically the information from Aidan. And it's not rendered here, but the setup is actually in the source. So if I go to show source, you basically see the source here. And what he did basically back then was the following, that he went to this AWS calculator and switched between the regions, and then basically copied out, probably with an scraper, which services are in which region. So if I switch regions here, you see that the number of services per region is changing, right? So now here are more services, US West as well, right? But you see it also changes. So that's what Aidan did back then. And I want to start with this at least, so that we have like a baseline, and then we can look a little bit on where can we get more current data from, because as you can see, this one has also deprecation notice, right? But I wanted to try and run Aidan's code first. So to do this, we need a new Aura database, an empty instance. So I kind of went to my Aura account, and I can say just create an empty instance, and click on this, download the credentials, and copy them here as well, and continue. And while this is setting up this instance, it takes a minute or two. We can actually look at the code from Aidan and then look at what is the data here, right? So I hope you can read this. The rendering is a little bit weird, but you can also copy this over into my editor. Let me just do this real quick. So this is a lot of services, as you can see, right? Okay. So I just copy this over to my VS Code. And So what do we have here in our code? So we have continents, which is obvious. The regions that were available back then. So he wrote this thing in 2014, but of course now we have, I don't know, 190 regions or something like that. In each region, they have availability zones, and then it maps the region to the continent and the availability zones as isolation levels to the regions. And then you have all these services here, the AWS services, right? So back then there were only like a handful. Now there's like 222 services or something like that. And then basically maps which region offers which service basically, right? So what we just saw in the UI, that some regions have more services and some have fewer services as such. And then after that, he also creates a number of instances, I think, EC2 instances that exist in the different regions. And they are basically served by EC2. So he has the instances, and he adds like the pricing, which is also from back then, the price per region for the different instances. And so you basically can see what costs what in these regions. So if you want to model this data, it would look a little bit like this. Let's see if our server is already running. Yes, so we can actually open Workspace, and we can do the modeling in Data Importer, so we don't have to.
Then that's easier.
We don't have to leave the tool as such.
Yeah.
Okay.
And this gives a good reminder, I guess, to don't forget to save your password. I mean, it kind of prompts you now very clearly.
Yeah.
You need to save
now you can download it. It's really nice.
Right? Exactly. You can also download it, so it's stored as one file on your machine, and then you can use it for connecting to it with other.
And you have this end file as well. Here.
Exactly. So it's super good.
Really
but
nice.
You need this password for you to be able to access. Neo4j does not have your password, so if you lose it, then you might be.
There needs to be like a hard reset of the password, basically.
Yeah, exactly. Yeah.
Cool. So if you model this, we can basically use Workspace for this. So we add a node. We said we have continents, right? Continent. We have regions. And within the region, we have availability zones. Availability zone. And then we have services.
Yeah, don't worry, Lenny, we delete this afterwards. Merkel deletes this afterwards.
Yeah,
so it's fine. You won't be able to break anything here. This instant gets scrapped after
exactly. And the service is available in certain regions, right? Or offers regions.
Yep.
So I need to look up the relationship tabs because I didn't remember them all. So continent, region is located in continent, and region has isolated availability zones. So we switch the order around here. It's located in. And then here region has isolated different availability zones. And then we have the availability zones, then we have services, right? And the region offers a certain service. So offers service. For service, and then for the different services. For service 1, we have EC2 instance type in service 1. So we can say here at node EC2 instance type. And then is EC2 instance type, and you can actually have here our service, which is EC2, and then we can basically connect it to this one.
Okay.
Is EC2 instance type. What else did we have in here? And then we have prices. So we have a price, and that's the region charges a price for a certain instance. So we have a price node, price. And so the different regions have different pricing. So the region charges a price for this instance here. For instance. And
yep.
So the price would have the attributes like name, description, cost per hour, and so on. And I think that's it in the model, right? So that's what IDAN's model looked like back then. And then you can start running queries on it. Okay. So far, so good. So we don't have the data here in CSV, but in a Cypher. But if you imagine we had this data in CSV, we could basically add the files here, the CSV files here, and then map this to the data. But here we can just copy and paste this into our query window and run this, and hopefully, yep. So it creates 111 nodes, 335 relationships, and a bunch of labels and so on. So, and now we can basically look at a core DB schema visualization, and it should basically render something like we had. As such, right? So that's very similar to our import visualization, right? Only the placement is on the other side. So we should probably pull this over here and then pull the region to the other side over here. So, and then it's basically the same data model as we just devised here as such. Okay.
Yep.
So, and now we can run a bunch of queries on top of this data as such. So what we can also do, we can also go to Nifty Bloom and just look at the graph there, which is our exploration tool. Let's see, show me a graph, enter. And then it shows us the graph data here as well. So you see basically here's an region, Ireland, and it has these availability zones. It's located in Europe. And then we can also say which services does it offer. And then we see all these services here, the blue ones are offered in Ireland and also in other regions as well. Right? So that's kind of where we can explore things as well, CloudFormation, Redshift, and so on. So the core services have been around for quite some time, actually. I think S3 has had like its 20th anniversary or something like that, almost. So it's been around for quite some time.
It's been around, yeah.
Right. So, and then let's look at IDAN's GraphGist here to see what kind of queries can we run on this. So for instance, one question is, what's the cheapest compute optimized instance anywhere in North America, right? So we would basically say, we find the regions in this continent. And then for all the regions in this continent, we look at the price that it's charged for the compute optimized EC2 instance. And then we return the AWS region, the price per hour, and the instance type, and then order this by the minimum price, which I think should probably not work. So we need to fix this query actually. So we go to query and paste this in. So I think there are a few bugs with this query. So first of all, this needs to be a label, and then this needs to be a label as well. So we find our USA regions and the prices. So we can probably start by just returning USA regions. So we have 4 regions back, or we had 4 regions back then, right? And then for the regions, we find the price for this instance type. So if we return just all this data, we should see we have the regions, the prices, and the instance type. We give it a name. So here are the instance types, which are all the ones that are compute optimized as family here.
Yep.
And so if we wanted to see the relationships as well. We can just return a path, and then we see these
relationships
as well.
Yeah.
Right. So we see here are our regions. Here are the blue ones are the prices, and the purple ones are the actual instances as such. Right? And then the remaining thing that I did is basically return the region, the minimal cost per hour, and then the instance type. And we should probably order by hourly cost. It's probably easier to understand. And it's ascending by default, right? So it's sorted ascending by default. And easy to. So this is in Oregon, was back then the instance type, C3 large, the cheapest one. So if you do a limit 5, then we see basically the top list, right? So there's actually another one in North Virginia, which is also 15, right? But then it goes up as such as costs, right? And these are also other sizes, right? So this is an X large, and this is a large, for instance. Okay.
And you can,
the next question
just fits perfectly from Lenny. Yes, you can export this table or any other table views that Neo4j browser renders as a CSV or Excel file.
Yeah. Unfortunately, it's not yet in Workspace, so that's something where we would have to switch to classic Neo4j browser. Actually, we can show how to do this. Actually, it's a good point. So you just go to your account, say switch to the regular.
That was a bit quick. Can you do that again?
I can do this again. Yeah. So in your account here, you have this blue box where you can switch between Workspace and the classic experience. So now perfect, it says Open Workspace. And if I click on this again, then I have 3 buttons here: Explore, Query, and Import. And here this query button opens Neo4j browser here. And we have to log in again. Let me find my end file. Where's my end file? There's my end file. And I copy the password again. So if you take the same query that we just ran here, run it here. And here we can download this data as CSV. And then cheapest instance USA compute instance. Right? So, and then if I look at it, then you see then here we have our CSV result as such. Okay, good question. So the next question is, which AWS region has the most availability zones? Okay, let's look at this. We pick our query again here. So we found our regions that have availability zone. All this is set. So this with behind the colon is the label. So we always want to use a proper label here. And I think he had an interesting. And it basically takes the region name, counts how many availability zones are here, and then returns it by descending order. So North Virginia had 4 back then, and now it's probably, I don't know, 10 or 12 or something like that. Right? Actually, in Neo4j 5, there's a nice feature that you can use. Is basically instead of doing it like this, you could also just say, give me the region, and then instead of count is that we would say this count and put in the pattern here.
Aha, right? Okay.
So we can just put in this pattern. So we can use the label or not, or without a label, it's actually faster. And then we just want to sort by this. So. And this will fetch every node only once, and then just basically ask the database for the number of relationships here. Right? And then this should give us the same result. If we use limit 10, then we see some others as well. But this is a special operator, basically, which fetches or looks at degree of a node, to say so. Right.
That's interesting. Yeah, so you can So you can use that to see the connectedness between. It's almost like a. It's not really a graph algorithm, but it's almost a little bit
it's
like
degree centrality actually.
Yeah.
There's this graph algorithm called the degree centrality, which is basically give me the node with the highest number of neighbors, basically, right? And that's actually what we're doing here, right? So we're kind of taking a graph and find the nodes that have the highest number of neighbors, so the highest degree for this particular type, as such, right? Exactly. So that's actually graph algorithm as such that you can run. It's one of the simplest ones, right? So because that's kind of not very sophisticated, but it's kind of a simpler version of PageRank, right? So where in PageRank you look at your neighbors, and neighbors. And here you only look at first degree neighbors, basically, which also is important, right? So because if you look at something like Twitter or social networks in general, each of them has a power law distribution. So you have a few people which have like millions or tens of millions or hundreds of millions of followers. And then the large majority of people has, between 1 and 5 or 10 followers as such. So you have like this power law distribution. And that's what you can basically compute with this as such, right? So you can then basically say, okay, give me the distribution on this graph as well. Cool. Let's look at the next question. The next question is, what are AWS regions that offer the service CloudTrail? So imagine you're building an CMDB or something like that, and configuration management database, and you want to basically add a new service, and you want to say, okay, this service needs CloudTrail support, so I need to find which region can I actually deploy it to, so that I get that as such, right? So, and you see that only some regions offer CloudTrail, only North Virginia and Oregon used to offer CloudTrail back then as such, right? So, so this pattern match is basically, so this should actually also be colon service here. This pattern match is actually find me all the regions, or it actually starts here on this side, right? So it finds the service with the name CloudTrail, and then basically expands off a service and fetches all the regions that are connected to this one service, right? So that's how it executes this this query as such. If you wanted to do it differently, so this is actually more efficient, right? But if you wanted to do this differently, you could also say you do an optional match here. So there are two other things. One is I say optional match for the service. So I find the service first, and then I do an optional match for the region, right? So that means I get a number. It's like a left join. So if it doesn't exist, the region, then it just returns null for this, right? So I basically get, oops. Why does this not? Weird.
Well, it should be the same answer, right?
No, because it's optional. So there should be actually regions with null here.
So it doesn't. I see. Okay, it should technically come back as a with an answer.
Yeah, really interesting.
Maybe it is only available in these two.
No, but that looks more like an. Or you could actually write where. You could do it this way. I think what probably works is if you flip it around. If you find a region first, and then do the optional match, I think that way it should work.
Yes.
So you find all the regions, and then you find the regions that have this service, basically. Okay, let's try this. So now we should get nulls here. So actually we get nulls on the other side, right? So we have regions, but they don't have the cloud service, the CloudTrail service as such, right? And the other way of writing this more recently is basically where you can say where exists, and then you can basically do this like this, right? So it find all the regions, and then for each region it checks, does this region have this service as such. And then I need to return. Oh, yes, yeah. So then I would basically get the same as we had before, but this is kind of a more, like that's also an efficient query, but the first one was actually more efficient because there's only one service and then you can follow the regions from the service as such.
Yeah.
Right. So there are a number of options to get there, but I think the first one was actually the simplest and was the such. Right. Then if I wanted to have another service, we can basically look in our create script here and say, okay, if you want to see the same for where our services here, for instance, SQS, simple queue service, then we can take this here and then I see these regions that give us the service. And so imagine you have a CMDB, a configuration management DB, then you could basically determine for all the services that your application needs, which region offers all of them, right? So I can actually say something like, imagine I do something like this. Then I would say I have my list of services that I need. We have the simple queue service, and we have let's say CloudWatch. So imagine we have these services. So we find a region, and then we say where all as in name in services where exists, and then we say our this thing here, and name is name and region for service. So basically what we say is basically for all the services in our list, it could be like 1 or 2 or 10 services, basically. It goes out the region and checks for each region. All these services need to be offered in this region, right?
Yeah.
All these names need to basically have this, right? If I would run this, let's see. Okay, all these regions offer these services, right? But we also had CloudTrail. So if you add CloudTrail, this one, then it should most likely be limited down again to the 2 that only had CloudTrail, right? So, and so that's kind of a way of doing this. That you say this. When you say any, then it would kind of at least one needs to be available.
Okay, good question. Yeah.
So there's any, there's none. So you could also say I want to exclude regions that offer these services, which doesn't make so much sense. And then there's also single, right? So exactly one service is offered. But here in our case, it's actually one.
Yeah. Okay. So in this case, you could almost run a net infrastructure of services you are running, and then you can see dependable dependencies. That's the word. Yeah. on certain servers or regions. So if you say
services, yeah.
my 2 crucial or 3 crucial services run on, what was it, North Virginia, and if this one has a server outage or some data problem, I have a problem because because this is actually the only region where it's available. There is no no fail-safe.
Yeah, exactly. So that was something that I wanted to talk about also a little bit later. Imagine you would add now your own applications to this, right? So I have application or microservices or whatever call this, and you would say an application, for instance, here depends on certain services, right? Here also depends on. Then you basically can say, okay, if for instance, let's say CloudTrail or EC2 goes down in a certain region or in a certain availability zone, is my application affected by that, right? So you can basically say, okay, I'm watching the AWS status things, and then I could proactively see which applications are affected, or more likely you could do what if scenarios, right? So you could say, okay, in the case that ABC happens, do I have basically enough fail safes deployed that allow me to do this as well, right? So you basically can really add your infrastructure to that, and that's actually also a common use case for Neo4j. So if you go to Neo4j.com use cases, there's actually a network and database infrastructure management and monitoring, right? So it's basically where people really, especially like banks, insurances, people that have larger infrastructures. There was a really good talk from Amadeus, the cloud booking infrastructure agency or company, how they manage all their server infrastructure and service infrastructure in Neo4j, which was really cool.
Yeah, because it's, I mean, we show here 3 services and things. It's very manageable for everybody, really. But if you are a big company, then you have not only 3, you have a couple of thousands. Yeah.
Usually it's thousands, right? So, but what's also cool is you can also extend this one step further. You can also say one application of mine or one microservice of mine or something like that depends on each other, right? So then you can also say, so if this service breaks, not just this application fails, but also the dependent applications fail as well, right? So you basically have these kind of transitive dependencies that kind of build a chain. It's almost like supply chain, basically, right? So it's a software supply chain, actually, to say so, right? And then you can basically model this. And that's what you would do, right? So imagine this was not an application, but this would be like a microservice or so, right? But usually I would call it service, but we already use service here for the AWS service. So I would call this probably AWS service or something like that, and then my own service. And then you can have one service and multiple applications to depend on the service, for instance, right? And then you could basically say, okay, or another service, another microservice that depends on this one, right? And then there's an application here, right? Or mobile app or whatever, right? So, and then you can really, oops, 1 second. I didn't mean for this one to pop up. Go away. For whatever reason, I introduced a bug here. Doesn't delete it. No.
No, it's gone.
Okay. So I would say here it's also depends on in here, right? So I would be able to say, okay, even my application depends on one service, which depends on another service, which then depends on an AWS service. And if something happens here or happens here, I basically can transitively see which of my applications are affected by it, or I can plan for it, or I can do what if scenarios, or if I need to do auditing. So many of our customers are finance industry or governments that need to do auditing of like robustness of their service networks, for instance, right? And cybersecurity, if you think about what happens if this service is breached by an attacker, so who's affected by that, right? So all these kind of things are in the network and infrastructure management space as such. Okay.
Can become very complicated very quickly.
Yeah. But it's also really powerful, right? So I mean, of course, but it's the nature of the underlying systems that are complex and complicated as such.
Yeah, right? That's what I meant. I mean, it's not the graph that's complicated. I mean, obviously it also can be, but imagine this is one scenario, and there probably other regions come into play again. Then maybe you have some other services that depend on other, not only on
pricing, for instance, right?
Pricing,
right. So you have stuff like pricing that comes into play. Capacity, exactly. Capacity. What about like latency and user requirements? What about geo-distribution, and all this stuff comes into play here as well, right? Which is really interesting. Cool. Aidan's next question was, which EC2 instance has most available memory, which is pretty straightforward because that's not really a graph query. I just fetch the instances and sort them by memory, and then give me the biggest one that has 244 gigabytes back then, which was a lot back then, and now we're at like 16 terabytes or so
sounds,
for the largest instances that you can get. Yeah, it's crazy. So that's kind of how I started to look at it earlier today. But then I thought about, so I found Aidan's stuff, and I found where he found the calculator that we just looked at, right? So this AWS calculator, which is about to be deprecated or removed. But then I just Googled for CSV data of AWS services, right? So where can you get CSV data of AWS services? So one thing that you can do is basically you can just run, let's see, terminal here. If I do AWS services list, service quotas list services, I get JSON back, basically, which is all the services of AWS, right? So there's all these services, right?
A couple more.
So what we could do is we could,
a couple more in the meantime,
200 or something like that, right? So what we could do is basically we can take this JSON, put it just into a GitHub gist. Let me drag and drop the file into that. Third one. AWS services. Okay, create public. Just save. And then what I need is the raw URL here. And then I can get this data and actually add it to my database, right? Which is quite nice. So what I do here is call epoch.json. It's in our file, and then just say yield value, return value, and then it basically returns one big thing because it has the services prefix here, right? So it's one big JSON. So what we can do, we can say unwind value.services as service and return service. Actually, what we can return is service.service code and service.service name. Okay, and this gives us a lot of rows, right? Where's my mouse? Here's my mouse. So it shows, what is this actually? 240 rows, right? I also just say return const, of course. And then I get also my 240 back. Right? But what we can now do with this data from AWS, we can just create new services in our graph, right? So we can basically say merge service with the name. So unfortunately, Aidan didn't have the service code back then, which would be better. But we have the service names, and hopefully he didn't do any misspellings. And then we say set s.code equals service code.
I also added it. Yeah, that's good. So we after the fact adding it in now that we have it.
Yeah. So if it matches it, then so merge is in get or create. So basically, if the data is already there, it just returns it. If it's not there yet, then it would create it and returns it as well. And in either case, we set the code as well. So if I run this, it adds 233 new nodes. So there might be some misspellings because we had a bunch of services in there. So no, 17, I think. It might be actually that he was correct.
There weren't too many, but I don't know how many he had.
Yeah, but if you look at this, how many rows are these here?
32 services.
Yeah. Okay. So there might be some misspellings.
Maybe some misspelling or some. I mean, names might have changed. It's
or adjusted, right? So, but you now see like all the. So some services also change from not having a prefix to getting AWS as a prefix, or AWS ELB versus ELB and things like that. So that's something that we could kind of also fix. So that was step number 1 in my journey. Then I basically found also on Reddit entry, which said that there's also an AWS pricing API that returns JSON files per region. So you see that the region name is in here, right? And so we can get this information from the pricing, and there's documentation for that. So we have an offer file and an offer index file, and these are basically just these URLs that you can get from AWS, right? So if this is US East offers, if I just load this, it's an index.json. Let's probably do this in the terminal. That's my terminal there. Terminal, and if we just run this here, then you see it gives us a lot of data, right? So we basically get different SKUs, compute instance, and then kind of the size of the instance, and then we get pricing as well for these,
as well as the location.
So, and as well as the location. So that would be my next step then, basically to get these details from here. That's the offer file, but there's also a simpler version, which is the where's this? That's the offers. I think this is the general one. So if you look at this one, this is just basically the service name.
Okay.
With the code, and then we basically see in this region, because you had the region URL here, right? US East 1. So we get basically everything that's offered in this region, right? And then there's more detail on pricing and other things in these other URLs as well, right? So that's what we could use to get the services per region as such. So the only thing that we now need is basically an AWS regions JSON API. And there might be an regions thing somewhere. Regions list.
There it is, isn't it? Oh, you need to
no, but no. What I wanted to have a global URL for that. Regions list. AWS region names, describe regions. It's probably here in the command line reference or something like that. Can just say AWS describe regions. Dash.
I think, yeah. Oh. Isn't it? There's all regions.
That's really weird. Yeah, I thought that. Easy to. Oh, you just say per service. Okay. That's also an option. You have to do it for each service separately, basically. So you basically get, for each service, you can get your regions. But there's also probably a region list somewhere that I can just get, right? And then use that, and we can add all our regions. So I think if I were to do this new implementation of IDAN's code, I would just use the AWS APIs to fetch the data directly from there, and then you have a complete map, right? And then you can get this from there directly. As such.
That's probably easier nowadays. Yeah.
And then what I really would do is basically, if I have a large organization, then I would basically map this out, and then I would map my services to it, right? So I would know which of my services are using which AWS services, and map microservices in our applications to these AWS services, and then I have a complete, basically, view, like a digital twin of my service infrastructure.
Yeah.
Right, so which is then really interesting for analysis, for finding like skeletons in the closet, like services that are not used anymore,
exactly.
or skeletons that are using outdated AWS services, or things that you want to migrate. Or you could also add something like a version number here on the relationship. So if you were here in the depends on, you could actually add like a version of the service that it uses, or you give the services versions, and then you can also see kind of what stuff is, for instance, outdated or things like that as well, right? So where you have these kinds of things, and you can get probably the information from your Eureka or Service Lookup or Kubernetes or so to see what your applications are using. So you don't have to do this manually, but usually you have it somewhere in an discovery service as such, right?
Yeah.
But I found it interesting that AWS has all these cool APIs where you can fetch this data about the price APIs, right? And then and so you get basically all the offers in all the regions as such, which is quite nice.
Yeah, I think it's interesting to think about this as not only interesting in terms of, okay, where's my infrastructure, like a digital twin you just mentioned, but also in terms of, okay, are there services we have, maybe we have a license for, but we are not using, or we have, I mean, because we would, but we can use it, which is a good thing, or which we don't need it anymore and we can get rid of. So in both ways this works, obviously. So and with that you can see, okay, actually this would be cool to use, or actually we don't need this anymore, but we still pay for it.
Yeah, so exactly. And then here you can basically see for one region you can get all the offers that all the offers services are offered there, and then you basically just iterate over the list of regions and fetch each of them. So what I would do here in Neo4j is where's Neo4j here? I would do something like find me all the regions, and then I would say call epoch load JSON, and then paste this in, and then instead of here I would basically say region.name and yield value, and then I think that was at least the region name. Let's see, not that it's an ID or something like that. Let's see. Scoff Cloud. Oh, it doesn't have the real names, so we would have to fetch them as well, right? So, but that's something that is possible, right? And then you basically, with these values, you would then basically merge the services and say then region merge regions, and then offer service and right, and then you basically can automate this as such. You don't need to do it manually.
Yeah, so. would probably just to make this clear, r.name is not what we're going to use. You probably use like r.url or something, or region URL, I don't know, and then
right.
Yeah,
or then identifier,
or exactly something we would have to. Like we have to
the human readable name, but the actual AWS region ID.
Yeah, exactly. Yeah.
And then here we would also use the code as the service code, right? So because here you have the in this you have actually the comprehend or AWS MWA or Amazon MemoryDB. These were the codes that we had in the in the file here, like comprehend, right? Or memory. It's not even MemoryDB in here. But it's easier to actually extract the services from what the regions offer than looking just at this region overview thing. Because that's also, it could be that it's actually limited what your account has access to, and it could be that my account doesn't have access to some of the services as well.
Yeah.
Right. So it's then probably go better via the offer file and then iterate over the regions as such. And that's basically 200 REST requests to the AWS API to fetch all this information, and then you can basically have all the details in there as well. Yeah, and that's it. That's what I wanted to show. And thank you, Reddit and Stack Overflow, for pointing us in the right direction.
Thank you.
And thanks to Aidan for doing the initial, having the initial idea in 2014, January 2014, to do this, which I found really as a nice. And it's kind of really funny to look at this. Like in 2014, AWS had 5 continents with 10 regions, 21 availability zones, and 2 services. And now it's like everything is factor 10 except for the continents.
No, they did not.
Right.
They did not add continents, but
exactly.
lots of other things they added. Cool. I promised we pushed this a little bit back. So coding with Ixor has one question. I think we can maybe squeeze this in. So it is very off topic. So that's why I said we'll do it at the end. Is it possible to put it on screen here? Is it possible to deploy Neo4j in AWS, and how does it compare with Neptune? Thinking to migrating our big database to a graph one, doing research. So, like I said in the beginning, talking about AWS and deployment, so you can exactly go to the marketplace if you don't want to use AuraDB, which is not your not the prime target for you, then you can go exactly to here, to the AWS Marketplace, and find the Neo4j Enterprise Edition, which is then self-managed. So you just...
This is self-managed, but for AuraDB Enterprise, it's actually centrally managed. So
exactly.
That's basically where you can use your cloud credits for purchasing Enterprise. And currently the team is working on moving or offering AuraDB Pro as well on AWS. I think that will come probably early next year as such. Not in December anymore, or perhaps I don't know if it will come in December or not. But
soon
might be
TM.
But it's exactly. And how does it compare with Neptune? So Neptune has a very different approach. And I mean, now they added Cypher support as well. So Neptune is basically a triple store, an RDF store, which offers Gremlin and Sparkle support. And only recently they added a subset of the Cypher language as support. And they also use the Neo4j drivers for that. And we've seen that people complain about performance and cost of Neptune in production because you pay per request, and then it basically in the background computes a lot of requests. But I would say do your own research and import your data into Neo4j, into AWS Neptune, and then make your own comparisons for the queries that you want to run. Because as you know, vendor opinions are always taken with a grain of salt. And so I always say people should take their own data, not use some artificial benchmark, and test it themselves. And because in the cloud, you can basically pay per use, so you can test it out and then make a informed decision. As such.
Or even if you don't want to invest any money, but up to you, you can always deploy a Neo4j locally and at least see how it performs there. Obviously, that's a different scope, so it's not a one-to-one comparison, but at least you can see how it handles. And then
and there are lots of deployment options for Neo4j, right? So if you go to Neo4j docs in the operations manual, there is installation on all the different systems, cloud deployments, Docker, Kubernetes, and so on. So there's a lot of options on how to deploy Neo4j as such, right? So in principle, you can deploy it locally on AWS, Google, and on Azure. And also you can just run Docker on self-managed container or on Fargate or something like that. That's what we do, for instance, for Neo4j Sandbox. These are all Neo4j Docker images running on Fargate on AWS, for instance. Right. So and Aura itself uses Kubernetes, so it has its own Kubernetes operator. But we also have an Helm chart for Kubernetes for the different systems as well. So that's also an option that you can use if you want to self-manage your instance.
Yes, Lenny, I think we showed this. Can you open the CSV file again, Michael? You downloaded. I think it wasn't visible on screen.
Yep. 1 second. Here is the CSV.
You need to put it on the screen. Oh, or is it here? No, here it is. Yeah. Okay.
So let's see.
You open it in interesting way of opening
it. Code,
Exactly. But yeah, if you imagine this is Microsoft Excel or
I can
other,
also, sorry,
any
I
other.
can also show it here in the download. Yes, this is here. So it's basically table, right? So
it's visible in every per row. And you can obviously define when you import Google Sheets or whatever, import a CSV file. You can decide how it's rendered. So
yeah, exactly.
it shouldn't
right,
be
so
all in one row. It should definitely be every row in browser is also exported as a row in the CSV file, and then you can import it in there. Yeah.
Exactly.
So yeah.
Cool. This was fun.
Yes, you just press download, exactly.
Very spontaneous and fun.
Yeah.
But that's why it's a live stream, right? So that's why we do this live. And
exactly. Yes, Lenny.
Just Lenny, exactly.
On the download button. That's currently not available on AuraDB workspace, but only in the classic view, I'd say.
So if you have this view, there's this on the right side here. This download button.
There it is. Little download button after you executed a query. Then little arrow, and then you download this there or a JSON as well.
Yeah. Right. And this had like 5 rows, but if I return like, let's say 100 or something like that, and download it, then I get 100 row in my CSV, right? So then it's here, replace, and then it's bigger.
Yep.
Right. So if I look at downloads, okay, there's too much in downloads. I have, for whatever reason, I decided to put this call bar on the other end, and then here I have more rows, right? So
yeah, exactly. Cool.
Super.
All right.
Cool. Thank you all for watching. This was fun.
Thank you for watching. We have, or I have 2 things coming up this week. I'd like to quickly highlight tomorrow at 5 p.m. Central European, so basically this time, but in 24 hours. There is Neo4j Live with 3 edges. So we talk a little bit about GraphQL challenges and best practices to avoid these with Alex, also another Alex, and on
Alex Squared.
Exactly. And on the first, the book club continues with Will and I. We talk about chapter 3, graphs in the database. So this is the first time we did chapter 1 and 2, which were my basics, and then establishing what is GraphQL and what can it do. And in chapter 3, we now add the database into the mix and do some exercises as well. So that's on Thursday. So I think little GraphQL week, and Michael and I will be back on Monday next week.
Yeah,
Monday.
as I said here. By the way, if you want to find this yourself, you can go to Neo4j events/events, and then just select live stream as the event category, and then this gives you the entries. And Alex does a great job of keeping the stuff always up to date. So
should all be in there. You can also subscribe to the YouTube channel. That's also a good point of getting a notification when we go live. So if you click on that and click on there's obviously Michael is logged in now, but you see subscribe button there. You click on that, then you can subscribe.
And you also see upcoming live screens as well.
See upcoming live streams, exactly, and you see here the notes.
And you have the notes playlist.
Well. Yeah. So that's
exactly.
That's that.
Yep.
Yeah. I hope you enjoyed the stream. Tell us in comments
what you want to see.
What you want to see as well.
Yeah.
And have a good rest of your day, rest of your week. Maybe I see you tomorrow or on Thursday or next week.
Yep.
Cool.
Super.
Thank you, Michael, again.
Thank you.
See you all and take care. Bye.
Bye.